In this video, we're going to explain what is the modern edge data stack and how it helps to generate operational and business intelligence. So first, let's look at the problem we're solving. At the edge today, there are various equipments and different data sources generating huge amount of data. And this data is actually very valuable because it contains a lot of information that companies can use to understand their customers, to understand their business, and to improve their equipment. And the data value can be divided into two major categories. One of them is called operational insights, or OI. The OI essentially is a real-time information that helps operators, technicians, and managers to understand how to work with the equipments and the data sources efficiently. And the questions they want answers to include what's the status of the equipments? Are they working properly? How do we improve the operational efficiency of the equipment? And can we predict failures in the equipment before they go down? So that's all real-time requirements, and typically they have a dashboard that they look at to understand basically the operation of the instruments and the equipments. On the other side, businesses can generate a lot of business insights, or BI. So business insights are typically done quarterly, annually, so it's not a real-time operation, but it's periodically to understand how data affects their business. Typical questions can include, what are the top features our customers are using in our equipment? What are the errors and mistakes they make in using them, and how do we help them to avoid those mistakes? Which vendors are providing reliable components and which vendors are not? So for the next generation instruments, what components should we use? So when a company is able to maximize operational insights and business insights, they are really using the data very effectively. And the modern edge data stack is designed to do this. The modern edge data stack essentially includes 5 different layers. The first layer is called edge data pipeline. That's basically the operation to get the data from the instruments and the equipments and validate, clean, adding contextualized information, and produce consistent high-quality data that can be used in analytics later on. And what's important is also to get that data in a common data model, which is the second layer of the modern edge data stack. The reason for that is because there are so many different types of data coming in at edge. Even for a single equipment manufacturer, you could have dozens of different equipment models, and those models may produce different type of data. So when you're able to convert all of your raw data into a common data model, that would make analysis much easier in the following stages. The third layer of the MEDS is real-time analytics. This is a layer where you're generating the operational insights. You can use analytics that are physics-based. You can use machine learning-based analytics. But the ultimate goal is to help to make the operations more efficient. And the next layer is data warehouse. So this is where you store your edge data, but also very often the OI results into a very large data warehouse. So you can use BI software, which is a final layer, to analyze the data and extract business insights. So when you are able to apply all 5 layers, you can effectively get the value out of your edge data. Now let's look at one layer at a time. So the edge data pipeline layer focuses on data acquisition, cleansing, transformation, contextualization. And typically, edge data is very inconsistent. and very often it's very noisy, and there's a lot of not very useful information in that data. So this is a very important stage to prepare your data so that it becomes very valuable and very easy to use at the end. And increasingly, a lot of the edge data pipeline is being directly executed at the edge using edge hardware like automation controllers or edge gateways or computers or even GPUs for AI-based operations. This is because by doing edge computing for edge data pipeline, you're basically distributing the computing loads to where your instruments and your data sources are. So it's much more efficient, lower latency, and also reduces your cloud cost. And that's a direction that the industry is going toward. So a edge data pipeline example is one where, let's say, you have a large number of edge instruments, right? So you could collect the data from this instrument using a edge computing device directly, in the plants or in the laboratories. Obviously, you could also send this data to the cloud to be processed if you want to. And a typical edge data pipeline may look like something like this, where there's a data acquisition step, and a data cleansing step, and a data contextualization step. And after that, the data may go into analytics, or they may go into a database or data warehouse. Obviously, this is a very simple example. You can add a lot of very complicated data processing steps in here to produce consistent high quality data from the raw data that you collect. The common data model is a very key component of the MEDS. This is because you wanted to have a single structure to define your data schema, define how you validate the data, and define how you transform from the raw data into that common data model. And once you are able to set up this type of model, you'll see that analyzing data becomes much simpler for both BI and OI. So real-time analytics is about extracting operational insights. And increasingly, people are running AI and very advanced analytics to do this. So you can deploy those AI directly at the edge. And typically, the results are displayed on a dashboard where you show relevant information for your particular application. And so that your operators, your technicians, and your facility managers can together to analyze and understand the operations of the equipment, and therefore they can improve the efficiency of their operations. Data warehouse is the next layer where you store your selected raw data or process data plus selected OI results into it. And then you can prepare for BI analysis in the next step. Typical data warehouses include what's traditionally called data warehouses, where you store structured data. But increasingly, people are also using something called data lake, which is basically where you can store unstructured data, any kind of data, just throw it in there, and you worry about processing later. And for edge data, because a lot of that data is time series data, and time series databases can actually be a very good choice for storing that data. I think all three methods work pretty well. Really, which one is the right answer depends on your particular application. So the final step in the MEDS is BI analysis. And this is an example, generic Power BI type of dashboard. Essentially now you're using a BI software to go into your data warehouse or even database and extract large amount of data, and you're looking for statistical patterns that can help your business, right? So generate, you want to have visualization You want to generate business reports for your executives. And with that data, you can get a lot of valuable insights out of. This is an example, MEDS architecture. And obviously, this is what we do. So it's a little bit of a shameless plug for our software. But generally, the architecture that you wanted to choose should be something like this. Essentially, you would have different type of equipment and instruments at the edge. And you wanted to be able to acquire that data and process that data locally, because very often you may have security requirements, or it may simply be more efficient to do that locally. And within that local edge compute box, you would have your edge data pipeline, data analytics, and even dashboards in here. You would have a local database where you would store all your raw data so that you can access them later on. And you would have many different sites, right? So this is a distributed system with many, many different sites where you need to be able to be scalable to support your global operations. And typically today, you would have a place in the cloud where you would design your data pipeline, data analytics solutions, and then you deploy them to run at the edge. And then the whole system is coupled with a data warehouse where you store processed data and OI results, and then you can access the data from a BI software for BI analysis. So this is a short introduction to MEDS, and certainly when you are dealing with edge data, edge equipment, this is a very important architecture to consider. Once you set up this right architecture, now you have a way to improve your data insights going forward. Thank you.